Alright, today we're going to be doing some stuff with right triangles with the trigonometry that we've been learning, and we're going to be solving some problems with that. So here's the good news. This is familiar to you from geometry. You've got sine of theta being the opposite over the hypotenuse. You got the opposite across from theta. Your hypotenuse is always across from the right angle. You've got your cosine, theta being the adjacent, the side down here next to the angle over the hypotenuse. And you've got your tangent, which is your opposite over your adjacent side, which are the two legs of the right triangle, so that can help you remember that a little bit better. Also, since we're working with right triangles, most of the time our angles will be in degrees, but sometimes they could be in radians, so that's where this pi over 2 comes from. Pretty much all this means is that if I have a right triangle and I have theta here, this is my opposite, this is my adjacent, this is my hypotenuse. If I do 90 minus theta, that gives me this other corner up here. Alright, and that other corner, if I'm going across from it, this would be the opposite for the other corner, this would be the adjacent for the other corner. So you can see that the cosine of the original angle would be the same as the sine of this new angle. So that has some useful applications. We will be doing more with those, and we'll see how that relates to the graphs of sine and cosine next chapter. But right now we're just kind of throwing these out here. Every now and then it could be useful to switch from one angle to the other. For the most part, the problems we're going to have are going to look similar to these, or where we have to find missing sides or missing angles or both. So here we're finding the value of the 6 trig functions that we know so far for angle A. So we also need to figure out what the hypotenuse is in this case, because we do not know how long that is. Here's your good friend, the Pythagorean theorem that you should know and be so familiar with. A squared plus b squared equals c squared. So we're going to do that real quick. In this case, our c is going to be the square root of 164, which actually can be broken down into 2 times the square root of 41. And then pretty much we just need to write our ratios. So sine of A is going to be our opposite, which is 10, over our hypotenuse. Now, that 10 and that 2 can go ahead and simplify a little bit, and then we need to rationalize. So that gives me 5 times the square root of 41 over 41 for the sine of A. The cosine of A is our adjacent, which is 8 in this case, over our hypotenuse. And we simplify that down again real quick before we rationalize. And that equals 4 square root of 41 over 41. Our tangent, which before we had to do sine over cosine on some of the problems here, we can just do 10 over 8. Which is 5 over 4. Which, if we put these two sine and cosine values together, we would end up getting that, but it's just easier to just use your right triangle. Your cotangent is just the opposite of that, the reciprocal of 5/4. That's what I meant to say. So that's 4/5. Your secant goes with your cosine, so your secant is going to be this square root of 41 over 4, and your cosecant is going to go with your sine. It's going to be the square root of 41 over 5. So again, these are some kind of the basic problems that you get when you see some of these right triangles and you see these ratios. Another one that you'll see with right triangles would be to solve for the missing sides and angles. So the easiest thing to do first is find that angle B. And since it's a triangle, you know that all the angles add up to 180, but since it's specifically a right triangle, these two angles add up to 90. So 90 minus 30 is what B is, which is 60 degrees. And then we can use 30 and 7 to find the other two sides. So if I do the sine of 30, 7 is across from it, that's the opposite side over my hypotenuse. And I do some solving, we see that C is equal to 7 over the sine of 30. And in this case, the sine of 30 is 1/2, and 7 divided by 1/2 is 14. And then for side B, we do the tangent of 30 because B is adjacent, so tangent's opposite over adjacent. That means we get 7 divided by the tangent of 30. And again, 30 is one of those angles that is on our unit circle, so we can actually do some work with that and get an exact answer. So I've done that in this case. So we have to multiply by the reciprocal when we divide. So that gives us 7 times 3, which is 21, over the square root of 3. And then I got to rationalize that. That gives me 21 square root of 3 over 3. And that actually reduces to 7 square root of 3 for side B. And just another one to run you through. Similar kind of idea. You got to find A, so we're going to do 90 minus 62, which gives us 28 degrees for angle A. In this case, I know the side again opposite of that 62. So for A, the little a, the tangent of 62 degrees equals 10 over A. And then A is going to equal 10 over the tangent of 62. In this case, 62 is not on our unit circle, so we actually have to type this into a calculator and get our approximate answer. And same thing for the hypotenuse. I need to use sine of 62 to get my opposite side over my hypotenuse. And if I calculate it out, I get 11.33. One of the things about these problems, and you'll see that we've got some word problems again with this, so we have to read the situation. So in this case, we've got a 33-foot ladder leaning against a building so that the angle between the ground and the angle in the ladder is 80 degrees. And then we've got some building that we're trying to figure out how high up the ladder reaches. So we draw our little building here. This is critical, right? Getting a good drawing. And we got a ladder leaning up against it. Here's the ground. And this angle is 80 degrees. This is 33. This is the height. Again, you've just got a right triangle here. And you got the sine of 80 degrees equals h over 33. And here we just multiply both sides by 33 and solve. And using our calculator again because we don't have 80 degrees on our unit circle, so we're not going to have an exact answer. That gives us 32.5 feet if you type that in. And just to lighten the mood a little bit, we're going to go to a short commercial break. So back to work. Again, the key to this and some of the other problems, make sure when you're doing these, and we're doing degrees on our calculators, that we're in degree mode. So a radio tower, 400 feet from a building. So we got 400 feet. We've got our building. We've got a tower. And somebody is looking at this tower from a window. So there's my window. And to the top of the tower, there's an angle of elevation that is 36 degrees. So that 36 goes here. And the angle of depression, if they look down, is 23 degrees. So we've got two right triangles here. And we're asked to figure out how tall the tower is. So pretty much we need two things. We need an A there, we need a B there, and our total height is equal to those two values added together, A plus B. So to find B, again, hopefully you can see my right triangle here with B in it. I'll make it in red. And my right triangle with A in it, I'll make it in blue. You can see the difference between the two. Again, they both share that 400. So that 400 is right here on the bottom of my triangle. So pretty much to find B, the tangent of 36 is equal to B over 400. And the tangent of 23 is equal to A over 400. So if I'm to work this out, my height is equal to find A, I do 400 times the tangent of 23 degrees. And to find B, I do 400 times the tangent of 36 degrees. And that will give me my answer, if I calculate that out, of 460.4 feet. So again, as you're doing these on the word problems, the key is to draw a good picture. So again, here we've got a triangle already. We know the height of the triangle is 82 down here in the middle. All right, and we have two of the angles. We're asked to find the whole bottom. So really, the key here is to split into two triangles. This piece being A and the piece over here being B. And then we can still use right triangle trigonometry because we've got a right angle in the middle of the triangle. So then we just have to set up two things. Number one, 39 is here, 82 is across from it, so that's opposite, and B is adjacent, so that's going to be tangent 39, and then it's going to be opposite of 82 over B. And for A, we're going to do the tangent of 63 degrees, and that's 82 over A. So my B value is 82 divided by the tangent of 39. And my A value is 82 divided by the tangent of 63. And using a calculator, you get the two numbers for that. So the first one, B, is equal to 101.26, and A is equal to 41.78. So my X value is equal to those two added up. And that's my total. So 142 and 74 hundredths is my final answer. So the key is just to remember how the ratios are set up for right triangles. If you look at your reference sheet, they're on there. You get a word problem, you can just sketch a picture of it, label things, and start figuring out what you know.